So let's steer back on. Let's get the fail road back onto the tracks and keep moving along. So let's talk about acid-base imbalance. So acid-base interpretation in human beings is really based on the analysis of something called an ABG. And an ABG stands for an arterial blood gas. ABG. And this is what it sounds like. It is a sample of blood that gets drawn from an artery, not a vein, right? Because venous blood is mixed. And so in some sense, it is a little harder to infer things from venous blood. It can be done though, but we start with the ABG, arterial blood gas. We draw a sample of blood from the artery, and then there are things that we measure in that. And what do you think the three major things are that we measure in arterial blood gas? Based on the three things we talked about earlier. We're talking about acid-base balance, so what are the three major things that we... CO2. Huh? CO2. Good. So we measure the PA, CO2, and remember, little a in physiology always equals artery, and then big A always equals alveoli. So P little a CO2 is a partial pressure, P equals pressure. Pressure tends to be in millimeters of mercury, physiology. So it's the pressure in the artery of carbon dioxide. Okay, that is one thing. What else? What's the other? What are the other two? Bicarbonate. Good, the bicarbonate, the HCO3 minus. Because it's an electrolyte, we tend to measure that in milliequivalents per liter. And then what's the last thing? It's essentially determined by these other two things. Spent like an hour talking about that earlier. pH, good. pH. These three values are what we use primarily, and we're going to add on to this. There's some other things we can add on to this, but start at the foundation. These three values are primarily what we use to determine the acid-base balance of the person. And then we also tend to look at one more value, but it doesn't tell us about acid base. And that is the P little a O2, the pressure of oxygen in the artery. And this is used to determine the oxygenation status of our patient. Okay? So pH, CO2, and bicarb are used for acid-base balance, and O2 is used for oxygenation. And that makes sense because these are the three variables that we talked about in regards to the Henderson-Hasselbalch equation, right? And I built that up, and we got to the normal pH. All right, so let's talk about these. So first of all, pH. So there is a normal range, and then there is normal, perfectly normal. All right, there's a normal range and there's perfectly normal. And you need to know the difference between these two in regards to pH, because it will help you understand something known as compensation when we get there. So the normal pH range, as we talked about earlier, is a pH of 7.35 to 7.45. And what is perfectly normal pH? 7.4. Good. All right, let's talk about the next one. P little a CO2. All right. The normal for PaCO2 is 35 to 45 millimeters of mercury. You guys okay there? And then the normal bicarbonate, HCO3 minus. Just think of the best years of your life. 22 to 26 milliequivalents per liter. So far, so good? And then the PaO2, again, this is not used to determine acid-base balance, but is used to determine oxygenation, is 80 to 100 millimeters of mercury. So these are the normal ranges and values of the various components of the arterial blood gas, or the primary things we're going to look at. Are you guys okay with that? Okay. So, let's talk about interpreting arterial blood gases. So if you look at this little table I drew over here, all right, arterial blood gases typically have three names. There are three names that you are going to have to identify for arterial blood gas. All right? First, a middle, and a last. Now, if the blood gas is normal, guess what? Normal, 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 right? It's just a normal gas. You guys okay with that? Normal acid base. Now, if it is abnormal, right, which is most of the gas that we're talking about, right, the first name is either going to be a normal, compensated, partially compensated, uncompensated, or mixed. You guys okay with that? That's what I get for my first name. Now, if the first name is normal or mixed, the middle name doesn't matter. You guys okay with that? So if I give normal or mixed for my first name, then it's the same for the second name, doesn't matter. Right? If it is not normal and not mixed, then the second name is either going to be respiratory or metabolic. You guys okay with that? And then it's either going to be acidosis or alkalosis, or obviously normal. Okay, so these are the names that we can assign. We can either have a normal ABG, we can have a compensated respiratory acidosis, compensated respiratory alkalosis, a compensated metabolic acidosis, a compensated metabolic alkalosis, right? A partially compensated respiratory acid, partially compensated respiratory alk, partially compensated metabolic acid, partially compensated metabolic alkalosis, uncompensated respiratory acid, uncompensated respiratory alkalosis, uncompensated metabolic acid, uncompensated metabolic alkalosis, or a mixed acidosis, mixed alkalosis. You guys okay there? Those are all of the names that you have to choose from, right? Those are all, that's the entire list of names that we have to choose from for our interpretation. But before we get there, let's break this down. So, there are essentially two ways that I can develop an acid-base imbalance in the body. And then you can combine those two ways. So far, so good? So the first way is I can have an acidosis or an alkalosis that is related to the respiratory system. Are you guys okay with that? Which of these three values, because these are the three values we look at for acid base, which of these three values represents the respiratory system? The CO2. Do you guys agree? All right, so the carbon dioxide tells us about the respiratory system. All right? You guys good with that? All right. So that's one way that we can get to an acid-base imbalance, is have a problem with the respiratory system. Why? Because carbon dioxide gets turned into an acid, right? Gets converted to an acid. All right. The other way is through metabolism. I can have metabolic problems. My kidneys cannot work. My liver can have problems. I can go into shock and my cells can produce abnormally large amounts of organic acids, right? Those kinds of things. These are called metabolism problems. Which of these three things primarily looks at the metabolic component of the body? The bicarbonate. Good. So the bicarbonate tells us about the metabolic component. And the pH is a pH, right? The pH tells us about the acid-base balance. All right? So far, so good? So the way that we want to analyze an ABG is we want to take a systematic approach. And the systematic approach that I recommend is in a few steps. So step one, look at the pH. Step one, look at the pH. And what I want you to ask yourself is the pH perfectly normal? Okay, if it's not perfectly normal, where is it? So, 7.35 to 7.39. And then 7.4 in the middle. All right. And then 7.41 to 7.45. So 7.4 would be what? Normal. Perfectly normal. If, however, it was 7.41 to 7.45, that is what I call base normal. Base is also known as alkaline. Okay? So base, alkaline mean the same thing. You guys okay with that? So basic or alkalotic mean the same thing. That's base normal, alkaline normal. 7.35 to 7.39 is what I call acid normal. It's in the normal range, but it is in the acid side of the normal range. You guys okay with that? And then anything less than 7.35 is full-on acid. And anything greater than 7.45 is full-on base, or alkalosis, acidosis and alkalosis. Are you guys okay with that there? Are you okay with that? Okay. That's step one. Step one is look at the pH, and is there a problem with the pH? If the pH is 7.4, is there an acid-base problem? No, right? You don't even really have to look at the other values. If the pH is 7.4, you know acid-base is good to go, right? And we would call that normal acid-base balance. You guys okay with that? If, however, the pH is in this range or this range, the ABG may or may not be normal. May or may not be normal. We don't know. So far, so good? If the pH is here or here, it is definitely abnormal. Are you okay with that? So if it's potentially abnormal or definitely abnormal, then what we have to do is we have to go, what is the cause of this abnormality? So you look at the pH to identify the underlying problem. Is there an acidosis or is there an alkalosis? Are you guys okay with that there? And then what you do is you look at the CO2 and the bicarbonate to determine what the cause of the acidosis or alkalosis is, and if there is any what we call compensation. You guys okay there? So far so good? Okay. So let's just work through a quick example. So let's say that we have a patient and I give you these values. Okay. So step one. Step one is look at the pH. What do we notice with the pH? It is acid normal. Are you guys okay with that? Okay. Let's look at the PaCO2. Is it high, is it low, or is it in the normal range? Normal range, right? It is normal. Let's look at the bicarbonate. Is it high, low, or in the normal range?
Normal range.
Normal. So if the CO2 in bicarb are normal and your pH is in the normal range, even if it's acid or base normal, we would call that ABG normal. Normal acid base. Are you guys okay with that? Make sense? Okay. Cool. Now, let's talk about the CO2 real quick. So the way the CO2 works is, CO2 is converted to an acid, right? It's converted to carbonic acid. So high CO2s are going to do what? A high CO2 is going to cause acidosis, right? Is that going to increase or decrease the pH? Decrease the pH. You need to remember this. Lower pHs are acidotic, right? For the reasons that we've already discussed today, due to taking the negative logarithm. So a high CO2 is going to be associated with a low pH, right? A low CO2 is going to be associated with a high pH, right? So a low CO2 means respiratory alkalosis, right? Alkalosis just means base, right? And a high CO2 suggests acidosis. Are you guys good with that? Okay, good. So let's look at the metabolic component. So a low bicarbonate means that you have low base. So that is going to be a low pH or acid, right? A high bicarbonate, more base, more alkalotic, higher pH, right? So the way that I remember this is the following. The relationship between pH and these values can be described as Rome. Rome. Okay? Respiratory, opposite. Metabolic, respiratory opposite, metabolic equal. So, the CO2 and the pH are going to move in opposite directions. A high CO2 is going to make the pH go down, right? A low CO2 is going to make the pH go up. That's respiratory opposite, right? And metabolic equal. A low bicarb is going to give you a low pH. A high bicarb is going to give you a high pH. You guys good with that? That's where the term Rome comes from. All right. So, let me give you another example of an ABG. So, step one, look at the pH. Is the pH acid? Is it normal? Is it acid normal or base normal? It's full on acid. Do you guys agree? It is less than 7.35. So it's full on acid, which means what? We have a problem, right? We have a verified, definite problem. Once I do that, then I have to go, well, what's causing that problem, right? Is it a respiratory cause, is it a metabolic cause, or is it a combination of respiratory and metabolic, right? So I go down and I ask myself, okay, CO2, is the CO2 acid, is it base, or is it normal? Okay, it's greater than 45, and remember respiratory opposite, so this is acid. You guys good with that? Does that make sense? And then I move down and I ask myself, okay, bicarb, is it acid, base, or normal? This is normal. So my primary problem is an acidosis, right? And what's causing the acidosis, just connect the dots. It is the respiratory system. So we would say that this patient has a respiratory acidosis. You guys go with that? All right, let's do this. Say the pH is 5. Okay, so pH. Acid, base, normal, acid, normal, base, normal. It's full on base, right? It's greater than 7.45. You guys go with that? It's alkalotic, it's base. Okay. So we definitely have a problem, right? So let's move down and go, okay, what's causing the problem? Well, let's look at the respiratory component. Is it acid, base, or normal? It's normal. So this cannot be the cause of my problem, right? Let's move down. Bicarbonate, is it acid, base, or normal? It's base. So let's connect the dots now. So my primary problem is what? It is an alkalosis, and what's causing it? Metabolic. This is a metabolic alkalosis. You guys okay with that there? So far so good? Okay, good. A metabolic alkalosis. All right. Now, at this point, we've figured out the middle and last names, right? So you now have the tools to figure out the middle and last name of the ABG, and now it comes down to the first, well, and part of the first, right? We talk about normal. We know how to identify normal. We know how to identify acidosis and alkalosis. Now what we need to do is we need to talk about compensation. And I would rather do compensation after lunch, right? So we can just pick it up and just have a whole discussion about compensation. You guys okay with that? And then, don't you worry, this week is where the homework starts, and you're gonna work through a boatload of ABG problems, so you can get more comfortable with this. So what I think we'll do is we'll look at lunch. I do have an exercise that I want you to do after lunch, and I'll show you where it is on Canvas here, so.